Up all night earlier this week,
Man.
John, thinking about my failed math experience that I had working with a couple students last week that are, like, let's say, fourth and fifth grade learners. Okay, so they're
Okay.
going into fifth, going into sixth. So they're 10, these kids. Okay, so over the summer, I was like, we're going to spend time on visual patterns. And so I have my son and a friend's child, and I'm just like, every week we're going to work through a pattern. And we're just going to, pick a
Love it.
different visual pattern, and we're going to commit to this for the summer. So I had them with me last week, and I'm going to try to share the pattern with everybody the best I can. I'm going to describe it to everybody. So if you are familiar with the pool problem, there's a lot of patterns like this, where essentially it's like you have these shaded areas in the middle, that's the pool, and then you have these white tiles around the pool.
Yep.
Okay, so there's different
Rectangles.
versions. Yeah. So there's these different versions of the pool problem. So envision, you have these shaded out tiles in the middle, that's the water. And then you have white tiles going around the outside, around the perimeter.
Just a bunch
Okay.
of squares. Some of them
Yeah.
are shaded.
Exactly. And they make, exactly like you said, rectangles. Okay. So the one that we worked on last week that kept me up, because I'm going to explain why it was a huge fail, is essentially you have in the first pool a single water tile, and then you have 8 white tiles around the outside.
So you all the way around. So all edges have a white tile attached to the shaded tile, but all corners, like vertices, also are touching a vertice of a white tile.
Exactly.
So you've got this really you have a 3x3 grid, and the center is shaded.
Is the pool. That's the water. Exactly.
Got it.
In the second pool of this pattern, you have 2 water tiles in the middle, and they're organized horizontally. And then your white tiles going around the exterior to make a rectangle. And then in the third pool, you have 3 water tiles horizontally.
Yep.
And then the white tiles are going around the exterior, making a rectangle.
All right. What we'll do also is we'll put a screenshot of that pattern up on the website. So if you're listening to this right now, you can open up your podcast platform, click the show notes link. It'll take you to the webpage that has the details about the episode, but it also it'll have the picture of this pattern there, and then in the other patterns that we do here. Okay, go.
Okay, so I'm going to tell you the wording for the prompt.
Yep.
It said, if you were to continue this pattern, how many white tiles would there be in figure 10, figure 20, figure 50?
Right.
So I worked with these 2 students separately. Okay, so I started with one learner, and I asked her this question. I was like, okay, how many tiles would be, around the 10th pool, the 20th pool, the 50th pool? And this is what she did. She counted the tiles.
Yep.
And she wrote the number of white tiles above the visual.
All right.
So for the first one, she was like, 1, 2, 3, 4, 5, 6, 7, 8.
Yep.
Then she went to the second pool, and she was like 10.
Got it.
And then she went to the third pool, and she was like, there's 12. She recognized, so remember, this is a 10-year-old. She recognized that this pattern was increasing by 2. So she was like, forget the pools.
Yep.
Okay.
Yep.
I'm just going to keep counting by 2. So she extended the pattern to the 10th pool, and she got 20. What do you think she did to get to the 20th pool?
She times it by 2.
She did. And I was sweating. Sweating. Because
why were
I
you
was
sweating?
Because this is why I was sweating. Because I understood her thinking, and developmentally, it was completely appropriate. Like, she was thinking proportionally. She was like, I'm just going to scale this. Like, I imagine that the 20th pool is going to have twice as many tiles as the 10th pool. But then I'm also thinking, okay, but this is developmentally appropriate for her for sure. But also, like, a major misconception that is going to potentially become problematic as she moves into, later elementary. The other reason I was sweating was because in the moment, I was struggling to not funnel her to the procedure. Like, I didn't want to do things like, well, back up to pool 0, or like I did, or like what's the rate?
Yeah.
Oh, this is an indirect variation, so you can't double, you can't scale it. So then I was up all night. So now I'm curious. I'm going to tell you, John, I approached this differently with the second student the next day.
You did the setup differently?
I did.
All
And
right.
I'm wondering if you can anticipate how I changed my prompt. So
You
remember,
changed the wording.
I did. So remember, in this one, it originally said how many white tiles would be in figure 10, figure 20, figure 50.
Okay. I see. Here's my prediction. Because as I know you and you know me,
Mm-hmm.
and you know, I think how we sometimes approach patterning problems when we actually create them is my guess is you didn't say how many. You said, what does figure 20 look like?
So I actually started, of course, with figure 10.
Right. Sorry,
So,
10. What does 10 look like?
Right. So I was like, okay, forget about the number of tiles. I don't care about the number of tiles right now. I just want you to visualize the 10th pool.
For sure.
And so when I did this with the second student, they were like, well, I know there's going to be 10 water tiles across the middle. Because in 1, there's 1 water tile, in 2, there's 2 water tiles, in 3, there's 3 water tiles. So I know that in the 10th one, there's going to be 10 water tiles across the middle. So then he said there will be 10 white on top, 10 white below, and then 3 on each side. Okay. So then I said, okay, well, what can you now visualize? So I asked him then, okay, how many tiles is that? And he was like, well, it's 10 plus 10 plus 6. So then I was like, okay, now can you visualize the 20th pool? And I said, don't even draw it, just close your eyes and picture it in your mind. And do you know that his gut right away?
It was 20, 20, and 12?
No. At first he was like, I think it's going to be 52. He also wanted to double it, but then he was like, but let me check. So then he visualized it. And he was like, okay, I'm going to visualize it. It's 20 on top, 20 on the bottom. Okay, plus 6, it's going to be 46. And then I was like, could you do 50? Could you do 13? Could you do 27? Could you do 184? And it's like, no matter which pool I gave him. So then I said, and remember, this is a 10-year-old. I said to him, could you write an expression that would work for any pool? And this was my favorite part, because this is why kids are amazing. What do you think he wrote?
I guess I'm trying to think whether his experience with actual expressions
Right.
are, but I would
So
say
I
it's
was
in
like-
words, right? Is it words? Like it was just like, you're going to add. No, I'm actually stumped here. What he would write as a 10-year-old.
So at first he said to me, it's pool number plus 3 plus 3. Because if it's like the 10th pool, it's like the pool number plus the pool number plus 3 plus 3. So then I was like, well, could we represent pool with P?
It's the pool number plus the pool number plus 3 plus 3. Yeah, I like it.
So then I said to him, what if pool was P? So he wrote P plus 3 plus 3.
Sure.
And I was like, imagine I had just funneled him to 2P plus 6.
Well, how would you have funneled him to 2P plus 6, though? Be like, hey, let me just show you how to do this?
Like I've done this with my 6th graders, where it's like I don't spend time in the visual pattern. I don't spend time with them making the connection between the relationship between, in this case, the pool number and the number of tiles. And I just tell them tricks like, go to the initial, throw it into a ratio table. Go to 0, see what the initial value is, look at the rate. That's going to be your...
Right.
Where in this case, it's like he generalized.
So you're saying those are the moves you make probably because you've already talked about how the rate relates to an expression and how the 0 row or the 0 term relates to an expression and all the pieces that actually make a linear equation. You're saying like, I've already probably done that work. So when I do a visual pattern, well, then it's easy to say like, well, what's the rate? Now write it in the equation because you already know where rates fit in the formula, in the structure.
Well, and
is that true?
That was my trouble with these 10-year-olds, is that I knew they didn't know any of that. Like they didn't have any of that experience, but I believed that they had the potential to access this problem functionally.
Sure. Now, here's a question, and I think it's likely, is do you feel like you got a sense of like when you talked about like what happens if it's P, the fact that they wrote pool plus 3 plus 3, obviously amazing. But then it's like, okay, now do we really know what the P means?
I think that in this case, it's like the P was like the figure number or the pool number. And that I think, but again, like that's a great question. And so we actually did another one like the next day to kind of consolidate this. So I think that yes, with that student, they understood that it's like the position in the pattern. So if this was the 20th pool in the pattern, then the number, if I would basically insert the number 20, so it'd be 20 plus 20. If it was the 13th pool in this pattern, it would be 13 plus 13. Yeah, I definitely I think that there was an understanding between the relationship of the position in the pattern and what they meant by pool number.
Okay. What do you feel like is your biggest epiphany, from this experience?
I think that my epiphany was, one, changing the wording. Like, it was like almost by asking the question the way that it was originally written by the number of tiles, it almost funneled students to pull the numbers out of the visual. Like, it's almost like by the third figure, they weren't even looking at the shape of the pool anymore. They were just going right to a numeric pattern. And by wording it that way, I think you lost the opportunity to leverage the spatial. So that was my big takeaway, like one of my big takeaways.
Because I was thinking, it's like, okay, so the fact that you changed here's, I think, the progression that happened here is that you gave the problem. With one student, you realized that you got stuck in a position where I had to funnel them to get to the answer that I wanted them to obviously know about the mathematics and how to solve a problem like this. So then you went back to the drawing board and said, how do I adjust this to get more thinking out, and that they could then access this level of mathematics without the pre-knowledge that was required for me to do the funneling. So like, I'm wondering is the epiphany, because I feel like the epiphany here that I'm hearing is that, because you keep saying that these are 10-year-olds now that have done this work and they've written an equation, and sometimes our 8th graders or teachers are right now going like, I can't get my 8th grader to do that, or my 7th grader to do that, or my 9th grader to even do this sometimes. So I'm wondering if the epiphany is like, you can get kids to access higher level mathematics by making some tweaks. It's like sometimes we make assumptions that kids can't get there yet. It's like, we can't do that problem yet because that's an 8th grade problem instead of a 6th grade problem.
And so I went back to the first student, right? Because I felt like I didn't do a great job with her. Like, we realized that she couldn't just double the number of tiles, but I didn't walk away feeling like she understood why. Right? Like, it's like she ended up, extending the pattern by counting to say like it's not 52. But why it wasn't 52, I hadn't really consolidated. So I went back to her and I gave her a new problem. And this one is the same idea. It's a pool. But imagine now, visualize that inside the water is a square number. Okay. So it's like it's 1, it's 4, it's 9. Like, it's going to be a square every time.
And then whites around the edge.
And whites around the edge to make a square.
We'll put this in the show notes too.
Yeah. Yep. So what was really cool about the second time that I did this with the first student, I did the same thing. I asked her, but I said, draw me the 10th pool. Yeah. Like, I actually want to see what the 10th pool looks like. And she didn't go there right away, but she started to focus on the water, and she realized by like the 5th or 6th that they were squares. And she was like, every time the inside is going to be the pool number times the pool number, like every time. So then I was like, well, what about the 10th pool? And she's like, well, it's going to be 10 by 10. There's going to be 100 water tiles in the middle. So then I was like, okay, well, with that information, can you figure out how many whites there are going to be? And this was what was really cool. She was like, okay, there's going to be 10, 10, 10, 10, and then always 4 in the corners.
I like that.
Like, every time. So then we went back to her doubling strategy, and we figured out why she couldn't double. And basically what she figured out is that what was happening is she was doubling the dimensions of that square, but she was also doubling the corners, when in reality, the corners were always 4. It's like, she was like, so originally, it's like it's 44 for 10. It's not 88 for 20, because it's actually, the inner circle can double, but then the 4 is always going to stay 4. It's like 4 every single time. So then we realize like there is a part of this pattern that is proportional where we can double the parts that are touching, but then we always just have to add 4. And this is a 10-year-old who was telling me this. Like she was coming to these conjectures on her own by really living in the visual of this pattern and not extracting the numbers.
Yeah, it's, I think what you're experiencing is the power of the visual pattern to explore linear relationships, nonlinear relationships, proportional relationships, and the fact that we allow students to say, like, take some wording, tweaking the wording to say, like, let's not focus on the number, let's focus on the visual, gets at the strategies that students are using to then say extrapolate and go like, what does the 10th, the 11th, the 11th, the 100th, the 150th, 1000th look like? And then using that knowledge of the visual to help build it. Because what I love about this is that one student said and again, this is going to be hard probably to start, because if you're not looking at the pattern, right, it's hard to hear like why it was, pool number plus pool number plus pool number plus pool numbers, like 4 pool numbers, then plus 4, because, you're not seeing the exact, because you've got that group of 3 in the middle, which is the pool number, or that the group of 9, which is, pool times pool. So the square of the pool number. But what I love is that some other student, like, I don't know if the second student visualized it the same way. Maybe I should ask you that before I share, because it's like, that's the benefit, is because the next student might not say that it's 4 pool numbers for the whites. I mean, 4 pool numbers plus 4 in the corner. They might say it's like, well, I've got pool number plus 2 plus another pool number plus 2 plus pool number plus pool number, right? Because you're going this top row plus this bottom row. Because the person, remember in the first problem, you were articulating that they were saying it's like figure 2 was like 4 and 4 and plus 1 and 1, and it's like, and then it was like 5 and 5 and 1 and 1, and then like 6, 7 and 7 and 1 and 1. Like the beauty of that is that now you get an opportunity to talk about equivalent expressions. Like if you do write it as an expression,
100%.
like yours is different than mine. Your formula is different than my formula. How is that possible? Like, well, how can we prove that? Like, what does it look like? And then this is actually how we begin. Like, it's funny because you think that you wouldn't use visual patterns to introduce algebra, but it's like, it becomes the reason that algebra becomes really important, is to show like these are equivalent, and we can use, say, some algebra techniques to show the equivalency. Is that, by combining like terms and talking about that, like this is how I've always began my, say, algebra unit, is to really tie it all into, linear equations and nonlinear equations, or patterns and nonlinear patterns.
So I think this is our call to action to, if like me, you love visual patterns, but sometimes you forget about them or get distracted by all the other amazing ways to, support student learning, maybe try a few, even yourself, like as an adult.
Well,
I think that it's a good exercise for ourselves to see them.
I would go one step further. You committed to doing one patterning problem a week, a day, a week, right? A week with those students for the summer. What I would do is you take 15 minutes, 10 minutes, and commit to saying, I'm going to do one patterning problem, one visual patterning problem to start my lessons a week.
Right.
For the first 6 months or the first 3 months, or maybe like if you're not in the patterning unit, it's okay.
Yeah.
It's okay, because by the time you get to the patterning unit, you've already done it. Right.
I think that the reason maybe I love them so much, and I know you do as well, is I often talk about, there's research out there, right? Like Taking Shape talks about the research around spatial sense. And it's like spatial sense is one of the earliest indicators of later mathematics achievement and proficiency. And so this is a great way to blend, even for early learners. It's like we're looking at counting, we're looking at patterns, we're looking at, changes and shapes. So I think that it's like time well spent. My go-to website, I'm sure many of our listeners as well, is visualpatterns.org. It's kind of my go-to. And what I did actually is I actually wanted to live in these particular types of patterns, linear patterns with an indirect variation. And so I just kind of looked through all of the patterns on the website and I pulled 8, that fit the goal that I had for our learning for this summer, which was to generalize this particular type of growing linear pattern.
Right. Awesome. Yeah. Visualpatterns.org. Head there. We've often referenced it here on this podcast in previous episodes. The creator of that website is Fawn Wynn. You can listen to her episode with Kyle and I on episode 259, Visual Patterns and Practice Standards, a conversation with Fawn Wynn. Go check that out. But great resource there. Build that into the work that you're doing. And we would love to hear about your progress, your pebbles, and your wins.